Hello students, welcome to OrganiChemVerse YouTube channel. Today I'm back with one more complex IIT-JEE Advanced level question. There are series of reactions given. You already know the structure of the final product. Based on the information given, you have to choose the correct statement or statements from the given options. How to solve such question? First, analyze what are the groups present in the final product, and then check for the conditions given and read out the options, because in some questions the options will help you to find out what will be the structures of the reactant molecules. So here R and S are diastereomers. They could be. U is hydrazine hydrochloride. It is a reagent. You can see there is a nitrogen. So U could be hydrazine hydrochloride. P can respond to the iodoform test. That means what? This might have an ketone functional group in the molecule, because when you look at the molecular formula, you see there is an oxygen. Q is 2-bromo-4-nitroacetophenone. So let's write down the structure of this Q, because it might be correct as well. So what is acetophenone? Acetophenone is a aromatic ketone like this, and 2-bromo is this, and 4-nitro is this. You see there is a nitro group in the final product. Okay, para to it there is some substitution happening, right? And then check for the position of the nitro and acetophenone. Look at this. Here it is at meta position, right? So with respect to nitro, ortho meta. So you see there is some sort of ketone group over here. So but here it is saying like para. May not be, it might be the isomer of this. So Q might not be 2-bromo-4-nitro, but it could be isomer of it. So with this much information, let's start writing what could be the structures of PQRS, and U, is it really hydrazine molecule? Let's find out what is the degree of unsaturation for C8H7BRO. The degree of unsaturation will tell you how many double bonds or rings are there in the molecule. Which formula are we going to use? 2C plus 2 minus H minus halogen divided by 2. For oxygen, you don't have to write anything. Oxygen is considered as 0. How many carbons are there? 8. 8 multiplied by 2 would be 16 plus 2 minus 7 hydrogens, and there is 1 halogen. There is a bromine divided by 2. So on solving this, you will get 5. So the degree of unsaturation for the molecule is 5. Students, remember when you write a molecule like this, right? A cyclic structure, degree of unsaturation will be 1, then double bond 2, then 3, then 4. For this itself, the degree of unsaturation will be 4, nothing but it's a benzene molecule. How did I know that? Because look at the product structure, that is also having a benzene, right? So the reactant molecule for sure is having benzene. What is the other degree of unsaturation corresponds to? As the name suggests, there could be a ketone in the molecule, because it's talking about the iodoform and then acetophenone. And if we cut the bond here, you can see that there could be a methyl ketone in the molecule. So the degree of unsaturation corresponds to the ketone functional group. Now, the important information you can see here is the degree of unsaturation for this molecule will be 5. There is one bromine. Where bromine could be? The bromine could be either at ortho, meta or para. But by looking at the product, you can see that the bromine is being eliminated. See, there might be substitution happening at the ortho position. So this might be our reactant molecule. Now let's check the formula for this. 6 carbons, 7, 8, C8. And how many hydrogen? 3, 4, 5, 6, 7. So 7, and there is a bromine here, and then there is a oxygen. Now if this is our reactant molecule, let's verify by doing all these reactions. Assuming the structure of molecule P with the molecular formula C8H7BRO as 2-bromoacetophenone. Let's carry out the given reactions and find out whether the final product is going to be benzisoxazole. This is the name of the heterocyclic aromatic compound. So now the first reaction is nitrating mixture condition. That means what? We are going to do mononitration for the molecule B. The electrophile generated in this reaction is nitronium ion. Electrophiles are electron deficient species. And what do? They attack the position where there is more electron density. So in this benzene ring where the electron density is more, how to find out that? So that can be done by the groups present over here. This is a ketone which is minus R minus I. How so? It withdraws electron from the benzene through resonance, and due to oxygen it is also exhibiting minus I effect. What about the bromine? Although bromine exerts negative inductive effect, it also exhibits plus R effect. Why is it exhibiting plus R effect? Due to lone pair of electrons. It donates electrons through resonance, making benzene electron rich. That means what? Between the ketone and bromine, bromine is the one which is activating benzene ring through plus R. That means the bromine is directing the nitro group either to ortho position. Ortho position is this and this with respect to bromine. But this ortho is already blocked and there will be steric hindrance at this ortho. Therefore, the incoming nitro will go to para position like this. Para to bromo we are talking. So what will be the structure of the product Q? Check here. The ketone will remain as it is and the bromine will also be here. With respect to this, we are introducing a nitro group. So this is product Q. We are getting two products R and S upon treating with molecule U. And what is this molecule U? Could it be hydrazine hydrochloride? How do we know that? Check the final product benzisoxazole. See, there is a nitrogen and oxygen. So that means what? This ketone is undergoing condensation with some nitrogen containing molecule. But what this X part we don't know because oxygen is gone and it's forming carbon nitrogen double bond. But what is this? Look at this molecule. The nitrogen is attached to oxygen. That means what? This X is nothing but OH. It has to be OH. Is this hydrazine molecule? No, hydrazine is NH2 NH2. So it is not hydrazine molecule. This is hydroxyl amine molecule. Therefore, option B you can rule out here only. Right? So let's use this hydroxylamine and check what products are we going to get now. After carefully examining the structure of benzisoxazole, we get to know that the compound U is nothing but hydroxylamine NH2OH. And whenever we have a ketone and hydroxylamine, it will undergo condensation and it will form an oxime. Oxime itself is a different functional group. You see here between carbon and nitrogen there will be a double bond and we are going to get an oxime like this, right? So if you look at the question, there are two products formed R and S, but here we got only one. Not correct, because we will get two products here. And what are those products? Geometrical isomers. How do I know that? You have to remember that whenever there are oximes, oximes exhibit geometrical isomerism, nothing but syn and anti, right? So if OH is on this side, the OH could be on the other side. The OH is anti to the methyl here. The OH is syn to the methyl here. Because of the restricted rotation of carbon and nitrogen, it is exhibiting two geometrical isomers, syn and anti. Now, among these two products, one is going to get cyclized, the other one will not undergo any reaction with sodium hydroxide. Why is it so? Look at this. The anti to the methyl, whatever is there, it is closer to this particular carbon. So when we use sodium hydroxide, it will remove this proton and it will undergo nucleophilic substitution reaction. Is this possible? Because we know that haloarenes will not undergo nucleophilic substitution that easily. No, it is possible in this case because there is a nitro group. Nitro is electron withdrawing group. Because of this, it activates benzene ring towards nucleophilic substitution reaction. Hence, we are going to get a heterocyclic molecule. We call this as benzisoxazole. So this will be our final product as shown in the question. So what is this product then? This is R. What about this one? Look at this. The OH is on the other side. Can it attack the bromine present over here? No, it cannot. That's why this will not undergo any reaction. No reaction for this, right? So when we assumed this structure and when we carried out all these reactions, we are getting the correct product. So that means what? Whatever we have predicted so far is correct. So using this much information, let's choose the correct options. R and S are diastereomers and S products are syn and anti-isomers, nothing but geometrical isomers. Since they are non-superimposable, non-mirror images, they are considered as diastereomers. Therefore, the correct option is A. B we have already ruled out. Let's check for C. P can respond to the iodoform test. Yes, this does give positive result with the iodine in NaOH. How so? Since it is a methyl ketone, the methyl part will form the yellow precipitate of iodoform and this will undergo oxidation to form the acid. So this is also correct. Now, is Q 2-bromo-4-nitroacetophenone? Let's check for Q. It is with respect to ketone. Look at this position. It will be 2-bromo 5-nitro, not 4-nitro. It is 2-bromo 5-nitroacetophenone. So this is also not correct. So among the given options, A and C are correct. I hope I made this question clear to you. If you still have any questions on this or any other question, please do ask your queries in the comment section. And don't forget to like and share my channel. Thank you.